So in this video, we will try to solve the problem number 33 of page 107 from the book of Wiley. So the given equation is y double prime minus 2y prime plus y is equal to x cubed e to the x. So we are instructed to solve for the complete solution for this equation. So analyzing the equation, we can see that this is a non-homogeneous differential equation of the second order. So in finding the complete solution for this equation, we first need to find the auxiliary equation for the homogeneous part of the equation. So in finding the auxiliary equation, we first equate this part of the equation to 0. So it then becomes like this. So in finding the auxiliary equation, we use this form where here a is equal to 1, b is equal to -2, and c is equal to 1. So our auxiliary equation now becomes m squared minus 2m plus 1 is equal to 0. So factoring this part of the equation, it becomes like this: m minus 1 is equal to 0. So equating both factor to 0, we get the roots. So our roots are m1 is equal to 1 and m2 is equal to 1. So this is a case wherein the roots are repeated. For the cases where the roots are repeated, our complementary equation is like this: c1 e to the xm plus c2 x e to the xm, where our m here is equal to 1. So substituting, we get the complementary equation, is yc is equal to c1 e to the x plus c2 x e to the x. So next is finding for y sub p. So in finding y sub p, we need first to derive two solutions from this complementary equation. So we label that as y1 and y2. So in finding the two solutions, we let values for c1 and c2. For y1, we let c1 is equal to 0 and c2 is equal to 1, so we get this y1. And for y2, we let c2 is equal to 0 and c1 is equal to 1, so the remaining will be e to the x, which is the value of our y2. So in finding for y sub p using the variation of parameters, we need to establish first these equations. So we need to find u1 prime, y1 prime, u2 prime, and y2 prime is equal to fx, where fx can be derived from our original equation. So this is our f of x. Next is, since we need to find the y prime 1 and y2 prime, we take the first derivative of these two solutions we derive from our complementary solution. So taking the first derivative, we get this y1 prime and y2 prime. So these are their values, and then using the Wronskian, and we know that to find u primes, we use Wronskian, and we know that u prime is equal to this equation, or we know this relationship where w1 and w2 are defined by these equations also. So again, going back to our plate, we find w first. So in finding w, we use the values of y and y primes. So here we put the value of y1, then y prime, y2 prime, and we get their products. We now derive the value of w, which is -e to the 2x. Same thing we do with y1 and y2. So here we substitute 0 and our f of x, which is from our original equation, to get y sub 1 and y2 and y2 prime. For y2, we use the y1 and y1 prime and replace y2's with 0 and f of x. So now we can get the values of y1 and y2 by operating these equations. So here we get y1 and y2. Now next, after getting these values for w, w1 and w2, we will now try to derive values for y prime, u prime. So we know now that u prime 1 is equal to w1 over w. So again, we substitute values, we get x cubed. So taking the integral of this equation, we get the value of u1, which is this x to the 4th over 4. So same thing we do with u2 prime. We substitute the values of y2 over w, we get negative x to the 4th, we get the integral, so that we get the value of u2. So now we have the values of u1 and u2. We also have values for y1 and y2. We can now get the value of yp by multiplying u1 by u2, u1 and y1 plus u2 times y2. So operating this equation, we get this equation, and further simplifying this y sub p, we get this equation. Simplifying this, we get this equation for yp. So now we have derived yp and yc, and recall that our yc is c1 e to the x plus c2 x to the ex, and then also recall that our complete solution is just this, the addition of yc and yp. So now we can, since we have yp and yc, we can derive our complete solution, which is in this form. So this is the answer for the differential equation given here.